Okay, and so now I just want to run through some examples of me doing our chain rule. So say we have some sort of function which is x squared plus 1 to the third. You can obviously uh, completely evaluate that term and then just use your power rule to solve, but that would take a very long time. So we can use our chain rule here, and we can say we can identify our f of x and our g of x. So our f of x is equal to x to the third, and our g of x is equal to x squared plus 1. You see how if we get f of g of x, we get our original function. So you want to make sure you're able to identify how you can separate the functions. So then we just need to get f prime of x, which we know is going to be 3x squared. And then we need to get our g prime of x, which we know is just going to be 2x. So then we can take our f prime of g of x, and we're going to get 3 multiplied by x squared plus 1 to the second, and then multiply by our g prime, and that's going to be x squared. And this shows us that the derivative of this function is going to be equal to 6x times x squared plus 1 all squared. There we go. So now we can do another example of this. Say we have something like e to the power of sine of x. What we can do is we can see that our f of x is e to the x, and our g of x is sine x. That would make our f prime of x also be e to the x, and that would make our g prime of x be cosine x. So what we can do here is we can see that the derivative of this is going to be equal to f prime of g of x, so that's just our original function, multiplied by the derivative of this g of x function multiplied by cosine x. So this is just going to equal cosine of x multiplied by e to the power of sine x. So you can use this rule to do some very complicated problems. It's very useful, probably the most useful derivative rule. And one thing I would just want to point out is that this uh, this is the power rule, or more, the power rule is the chain rule. Because if you look at this, say you have y equals x squared, and you want to get y prime. If we were to use our derivative rules here, say we say f of x equals x squared and g of x equals x, which is true because if you plug in x for x, it's just going to be x, then f prime of x is going to equal 2x, and g prime of x is going to equal 1. So then if you plug in these rules, you get f prime of g of x, which is just going to be 2x, multiplied by g prime of x, sorry, there's supposed to be a prime there, which is just 1, multiplied by 1, we get that the derivative of x squared is just 2x, which we can also get using our power rule. So yeah,